friends, this is me, Vishwasnayan. I'm the host of this podcast. A lot of times, data technology has been overpriced in some extent, but also there is a lot that we need to demystify over a course of time because it's scaling towards a whole new jargon on its own, right? Data mesh, data lakes, there are a lot of things, but we are here to solve the problem statement and not making you feel that what every day people are adding new technology. And this podcast is not going to give you an example of what technology was, but this podcast is going to give you what technology is going to be and how we are going to address the data technology ecosystem problem statement from today. So thank you so much, Jitendra sir, for being on the show. Means a lot.
Thanks, Vishwas. I think thanks for the introduction and thanks for inviting me on this podcast. So I'm very grateful to have you to basically have me in your podcast. So I'll try to give you a very short intro of myself, right? Then possibly
Sure.
we can start the next step. So again, having said that, myself, Jitendra Sir. So I have been working as a data engineer in the industry like from past 3 to 4 years. I started my career in 2019 as a data analyst and basically move on to the data engineering background, right? So having said that, as I move on the data engineering career, like my major focus was basically building the data platform, right? So when someone thinks of the data platform, they always think of two use cases, right? One, the batch and the real time. So in my past experience, I have mostly built the real time or let's say the streaming applications or let's say the pipelines and also the data platform like where a batch use case comes with the data lake or might be a lake house architectures. So this is what I have been working on. So my basically data journey looks from the beginning of my career and till now I've been building the platform and working as a data engineer.
Right. So yeah, that's pretty awesome. So let's start with it. How to get involved in the area of data management. So there's a lot of question that comes to me, like saying that, which was, should I learn Panda? Should I learn Dash? Should I learn a new framework which is coming up from a new company which is coming up with their own jargon? I'm like, you know what? Let's not complicate it. Let's talk it in terms of data management rather than just going out there and figuring out any other jargon that we want. So how to enter or get involved in the field of data management today?
Okay. Okay. Let me give you first a very brief on the data engineering, right? Basically. So people started looking on like as you said, like Panda, SQL, they need to be very proficient and basically they can start over there, right? So a simple role of a data engineer is to build a pipelines. I think everyone knows, right? So what we do generally is data is sitting in one place, so we just need to move into another place, right? Having said that, we need to make sure like the data what you want to retrieve or let's say fetch from that particular source, it should be much more efficient than what has been there in the source, right? That is the one goal what we do, right? Now, coming on to the data management, it's a very critical aspects like when we start building the platform, right? So in real world, right, or let's say in industry scenario, your data is sitting in different places, right? And the formats of the data can be structured, unstructured, and also semi-structured, right? So you need to know like what data need to be managed and how it need to be basically placed in one particular source, right? So coming on the data management, first we need to identify like what kind of data we are dealing with, right? And we need to understand the format of the data, right? For example, most of the backend, right? Or if I talk about microservice architecture, right? They choose a transactional database as the data store, right? So they store the data in a relational databases. So that is how it looks. Now, if I have to talk about non-transactional data sources, like they basically go with the NoSQL database, and there the more updates, the data will not be getting updated, right? So that is another aspect of the data. Now, as I said, data is being managed differently in the source, right? So the same thing thinking we come and we basically try to solve the problems what is being there. So looking on the basically looking first on the users, right? What target users or let's say what audience we are targeting for our data use cases, we need to build our data platform, right? Based on the data platform, we need to do the data management, like what formats of the data we need to manage, right? Now coming on to the tech or let's say the tools what need to be used, right? So in data engineering there is a plenty, or let's say n number of tools available in the market, right? Or might be the technology, I can say, right? One can use let's say any kind of a connectors to connect to this data and basically get into the platform where it can land, right? One of the most very basic scenario, what I think is people should know any one basically programming languages they are aware of. It can be anything. It can be Python. It can be Scala. It can be Java, right? And second, to basically fetch this data, most of the time, or let's say to read this particular data set, they need a SQL knowledge, right? And SQL can be, again, it can be MySQL, Postgres, Oracle, or might be MS SQL, right? So any language, or let's say any SQL is enough for someone to manage the data. The only thing is they need to understand the internal architecture of the databases, or might be the data store what they are choosing, so that they can efficiently store the data and basically access that particular data.
True. I think that's the whole journey of a data engineer. He always says the story with the data, and it's always something like, what, somewhere down the line there is a security threat in the data that we are collecting, and that will be known because of a data engineering pipeline, because it's huge amount of data coming in, and we are coming up with a new concept called as data mesh. I think that's a whole new strategy that we are playing together with. So let's start with this question of, can we provide a definition of data lake and data mesh, or any of the new jargon that is coming up, and discuss some of the problems that they possess and also they solve over a course of time. What are some of the organization and the industry trends that they can do? Because every time when there's a new jargon, everybody says, what, I think probably industry had too much time and now they rigged up a new jargon out there. So there is always a misunderstanding that goes behind it every time there is a system that is coming up. So what is an absolute definition of a data lake, a data mesh, and how are they going to impact in the industry over a course of time?
Okay. Yeah, I think that's a good one. Basically, currently this data mesh or might be a data lakes are trending in the market, right? So let me give you first come back on the older system, right? Or let's say the traditional way of handling the data platform, right? So I remember like when this big data ecosystem came, right? A big data, I can say, right? When people started managing the data, they always think about a, a data warehouse kind of a solution, right? Where you build a warehouse, all your data will be dumped over there, and you basically access over there, right? So what a data warehouse is like, they brings your storage and compute tightly coupled, right? So one of the challenges in the older days, or let's say the early days, most of the data engineers, or might be the a big data kind of a world we faced was the rise of the data, and with rise of the data you have the cost associated to that, right? Which, since storage and the compute was tightly coupled, so once you increase the storage you get the compute being charged over there, right? So that was the big problem, or let's say the big challenges we faced on building the data warehouse, right? Then slowly we moved on to the data lake kind of a concepts. Like a very simple definition of a data lake is like something. Just think about a lake, like where all your data source, all your waters are coming into a lake, and then it's getting dumped into one place, right? So the similar concept is of the data lake, like where you store all your data and just dump it. Like you don't care about like who is accessing that, and basically what particular use case will be there, right, at the beginning. So it acts as a data lake, right? There will be further processing a later point of time, but for now you can just think a data lake is nothing but a storage which where you can dump all your data sets, right? So what problem we solved with data lake? The challenges was data warehouse, like storage and compute were tightly coupled, right? With data lake, we were able to store a huge amount of data, incurring very little amount of the cost, right? And since we need to have a compute separate, we can just charge, or let's say we can get charged only for the compute, or let's say the compute layer what is being used, right? So that was one of the benefit, and one was the big change, or let's say that happened on the data world, right? On the big data world. So data lake and the Hadoop, I think it's a similar kind of a concepts. Like this plays a very important role, and they have been lasting in the industry for a couple of years, right? Slowly, again, we faced our challenges, right? Where our data lake is nothing but an object store, right? Where you start dumping all your objects. So one of the big challenges was to access this particular data, right? Like if you start accessing, let's say 5 years of data, which is being a kind of a objects split it into small files, right? So consuming this data, processing it takes a lot of time, And that is where your computation charge started increasing, right? Whenever you start using it. So to solve this problem, I think a new technology came, and that basically called as a lakehouse kind of architecture, right? Where you can basically build a incremental updates in your data lake, getting the features of the let's say transactional updates, right? So data lake was most probably like all the insights that was happening before. With Lakehouse, you were able to achieve the transactional objects, what can be done on the data lake on top of data lake. That is one. Second, like reducing the problem of the small files, right? As I said, like so we need to compact that files, and there are a lot of technology in the market currently which does this job out of the box, right? Naming few of them are like Apache Hudi, Apache Iceberg, and Apache Delta, right? And Delta Lake is the one Databricks product which has bring these concepts Lakehouse at the beginning, right? So Lakehouse was solving all those problems like what a traditional data lake was facing the challenge, right? Slowly, I think what I see in the company is like when a team grows, your data volume grows, right? You have a central data team which manage all this particular platform, right? So you started getting a dependency on the central team. Like if any data source you need to get, you need to connect with the data engineers which is managing the central data platform, and they need to get the data from the source and basically provide access to them, right? So this is fine for a small organization where you have like 100 people working together, right? Or might be your audiences, or let's say your target users are 10, 20, or might be 50, right? For bigger organizations, right, where you have a separate domain, let's say finance deals their own data sets, right? Marketing team deals their own data set, right? So this started challenging them like to get this data in time, and they basically cannot take the insights out of it. So this is where the data mesh kind of architectures came in play, which is nothing but a kind of a domain driven kind of architectures where you start building the platform, or you start building the self-service platform for independent teams, and they are capable of basically onboarding the data sources what they need in the platform, and you as a central data team manage only the governance or might be the access part or the documentation part of it, right? So data mesh is nothing but you are building the data lake into different domain, or let's say a lake house, it can be anything, right? And as a data mesh, you are just controlling the access among all this particular data product and bringing the central data governance layer which can access this particular data. So what did we solve here, right? We solved the problem of like dependency. People were easily onboard the data what they need in time, and they were happy to get the insights in time. So that was the major challenges we try to solve with the data mesh architecture. But in holistically, it is nothing but a lake house or a data lake basically sitting in different domain product.
All right. I think there is always a new beginning for data technology, right? But there are some challenges that arise in this data mesh approach, or anything that is coming up. So, what are some of the challenges that arise in the data mesh approach, and how are they more eased out when compared to a data lake architecture? Because data lake has its own set of problem statement that, as you told, but there is something beyond everything that we always incur as one of the problem statements in data mesh. So what are the problem statements that arise when we try to build something known as a data mesh as one of the key architectural practices in an organization, and how are they going to make us feel the ease of deploying a data lake compared to data mesh compared to deploying a data lake in that scale? Because scale is something that we define here. The scale of data
Correct.
that is getting ingested is getting defined here. So how is it going to be different than the problem statement which arose when there was data lake in an architectural practices? But what happens when there is a data lake as one of the new practices that we are coming up with? So you can also talk in terms of what happens when a data lake architecture to data mesh architecture migration challenges are, as well as what
Mhm.
are the other challenges that people can face over a course of time.
Sure, sure. Yeah, I think what you said, definitely there are few cons of the data mesh architecture also. So first thing, when should people go for the data mesh architecture, right? So they have to be very clear with that. As you said, the data might scale or might be you are handling with a very huge data sets, right? Data mesh architecture always play a very important role. Like when you have a very big team or let's say the very big data consumers which want to access the data, and they are facing the problem with the getting the data in time, right? So that is one. Second part, you talked about the data lake versus data mesh, right? So as I said, like whenever you go with the data mesh architectures, you basically building the data as a product, right? So every team has their own platform, I can say, like where they can access the data. Having said that, let's say a finance team is having their own data lake being set up, right? So there can be a use case like where a finance team might want to access some kind of a let's say a user catalog, right? A users that becomes the master data for everyone, right, within an organization. So we need to think of it like that users has to be dumped into the, let's say, finance data as a product or a marketing data as a product. So that differentiation, it will be quite difficult, and you might end up duplicating the data into different domain, right? Basically data like kind of example of an inventory or might be a product catalog, right, which you need to duplicate, right? So duplication might occur. That is one. Second one is sometimes there can be a link between a data from finance and the marketing, right? So let's say a marketing team does some campaign and they started getting the data in their own domain product, right? Then later point of time, that campaign will start becoming the transactions, right, by the user. So users might do some transaction and there will be some finance data or let's say the payments data that might be collecting it. So your payments data might be sitting in the finance data, right? So there is a use case where you need to cross join this particular data, right? And that is where the data mesh is helping us to cross join this data with the central data catalog, I can say, right? So when you have a central data catalog, there is a data transfer cost that might arise when a data movement happens from one particular domain to another domain, right? So that is another challenge we say, like what cost you get incurred from the data transfer cost, right? So that the second one. The third one is like basically making the pairing of this access, right? Like as I said, like as soon as you go with the data mesh architectures, your different data domain might be sitting in different VPC or might be virtual private VPC or let's say networks, like which you need to enable the pairing so that data can be accessible, or let's say interoperability, we can make it so that data can be moved from one place to another, right? So these are the challenges what you see like as soon as you go with the data mesh architectures. And the last point is the basically providing the access to the users, right? So you will end up providing access to other particular data sources which they might not need and they might not be aware of, right? So we need to make sure like this, we need to basically have a very thorough documentation or the, let's say, a security policy which defines like what roles or what access a user should have and they basically have that access. So these are the challenges what we see in the data mesh architectures.
I think that's a very fair definition of security that you brought up, because I know for sure there are hundreds of companies out there that are not Kubernetes ready. They are not
Agree.
Kubernetes ready, and there are some applications which are still legacy applications. And I was like, there was a job role which got opened, and they told mainframes, and I was like, is there somebody running mainframes still today? I'm like, who runs mainframes today when there is already serverless which is ruling the market? And of course, even serverless is one of the sources of data mesh, right? There are a lot and lot of triggers that we want to generate using Azure functions, and we want that to be as one of the data in the data mesh as well, because everything is connected. Not just I own an MX Master 3 here. Like, this is an ultimate machine which I could buy, and this is connected to three of my devices. Who knows, any one of the devices can be hacked. and
Correct.
and that's how it is. So it's a very valid point about security. So let's just move out a little bit of off topic, and let's talk about how can a cyber security practice bring enablement in the data mesh security that we are talking. Because I know this is off the topic, but let's just cover the fact that there is a requirement of DevSecOps culture even inside the data mesh. So even a tool like Devtron, we always think security, security. Is there any security vulnerability that an package that we are using is facing and things like that? So there's a lot that we always talk about. So how is data mesh going to enable the new age DevSecOps, or is the data security operations that we all dream about right now?
Okay. Okay. Yeah, I think security has been already a major hot topic, I can say, in the industry, right? As you said, like most of the news you can see, like a data leakage that has happened from the company, right? So that becomes a big threat for for an organization, not just particular team, but as a wider group, right? So you should always think about the data security, right? So if I have to categorize this data security, there is a two aspect of it, right? One, how do you store the data, right? And second, how this data is being accessed, right? So talking about again how data is being stored, right? So there are a couple of data security aspects what you need to look up, right? So first one is looking on the data protection side, right? Like how data is being stored. So what I generally follow, like whenever I start building this data mesh or might be a lakehouse kind of architecture, right? So your data should be encrypted at rest and also in motion, right? So data coming from your sources and basically flowing back into your platform need to be encrypted so that any third party users, whoever is reading this data, they should not be able to read out the actual data, right? That is one. Second, there is a chances like your data might be accessed by some third party authorities, right? So when they download this data and dump into the system, right, they should not be again actually read that particular data set. So that is what we call as encryption at rest, right? So that to practice we should always enable like while building the platform. Okay. Coming into the second point, right? Accessing this particular data, right? So this is basically we talk about the challenges of the data governance, like how do you know like who have access to what all data and what people are accessing what data, right? So it's kind of a data audit log, I can say, right? So in terms of data lake uses audit, you should be able to enable your data lake uses, like where how frequent the data are being accessed by the people and what volume of data they are basically downloading, right? So with that you can basically make a let's say you can basically monitor your data uses and make an actions out of it, right? You can just see like someone's might be downloading entire data set, right? The volume of the data what you can enter as a threshold, like which can basically flag out like this particular data has been accessed and this is an unauthorized kind of access. So it's kind of a users pattern what we say. That is one. Second one is the compliance issue, right? We generally face like it is not just like company or let's say some third party or the hackers being hacked by our data, right? We also comes under the government policy like a kind of a GDPR or might be some other compliance policy, which says like whatever data or whatever users data we are storing, if user requests us to delete, we need to delete from our ecosystem. So this becomes very challenging, like as soon as you start building the data platform or data pipelines or the data mesh architectures, right? Because your data might be deleted from the source. You need to track it, and you might have built different layers in your platform, like where but that particular data is being stored, right? So the solution is like you should build a system where should be able to you should be able to capture the deletion that has happened on the source and basically apply all to your downstream services. So you should choose your frameworks or might be the architectures in a such a way like you should have a deletion kind of a capability, right? That is one. Again, within deletion you have two kind of a delete, like where sometimes you might need the transaction data for your future audit purpose or might be analytical use case, right? So that we call as a soft delete, like where you delete the pi data of the users and you basically keep the transaction that has happened for that particular user, right? So these are the couple of security aspects what we think like whenever we deal with the data. Now talking about the data leak prevention, right? Like that what happens generally, what we can do is we can have a monitoring capability like what all tools or let's say what all users that are basically accessing this particular data sets, and if we identify any users like which are anonymously basically accessing the data, we need to flag out and we need to stop the access to that particular user. So that's what I generally prefer on building the data mesh architecture.
I think that's a fair choice that they have to make. When it comes to organization growth doesn't happen just without security being a next checklist after rigging up the software stack. Today security is an security is a checklist before you think software building process. Like, you define an SDLC, sorry for that. If you don't have the security strategy, sorry for that, I'm not working. That's what developers say today, because they are all, you know what, security savvies. They really want security as in first choice. So one of the intended benefits of data lakes is the idea that data integration becomes much more easier than having everything at one place. That means a business person still has a story to say using data lake, and software engineer still has a story to say using a data lake. Data integrations become much more easier and faster. I think the way SaaS got defined was because they had more data, they had more user experience data that was coming up. As an user experience guy who doesn't understand technical jargons, he was understanding what was given to him in front of him. So every single day, there was a challenge that was getting solved. But experience has been changed, and with regards to the performance, there's a lot of changes that has come up. So how to approach the challenge of data integration where the architecture is domain driven? Because everybody, let's say me as a security professional, when I go out there, I really want to say a story of how secure my system was. But everyday schema is changing, so there's always a schema change that has to be taken care, and there has to be a data integration approach that is just changing every single time. So how to approach the challenge of data integration when it's a domain driven mindset that is driving that kind of a practices? And particularly, there are a lot of data semantic consistency, there are always and schema evolution, and a lot of things are happening. But this also comes at a cost where we also feel that there is a latency in the system that is popping up. So there is system performance, there is data consistency, there is data latency that we are talking about. And training a model, because we believed in data lake, was much more easier and faster. So how is data technology solving the problem of the consistency of the data, which is just going to be the same, the readiness with respect to evolution of schema, that is also what we are also talking about, and being domain driven is something that is more challenging today. So how do you think data technology practices today is addressing all these things? You can address it in terms of data lake, data mesh that you saw in the industry for a very long time, and how is it changing today over a course of time?
Okay, got it. I think I'll try to categorize this particular questions into three part, right? So what basically we are trying to talk about here is the data freshness problem. What we see, you said about the schema inconsistency, like let's say a data consistency, I would say. And the third one is the schema evolution, right? Or the schema evolution that has happened on the source, and how we do we basically manage on the data lake. Okay, so let's go one by one, right? So talking about the data freshness, right? So this has always been a challenging task for any data engineers, like where you need to make sure the data has been refreshed very quickly, so that our data consumers or might be the analytical users can make the insights out of it, right? So what I can suggest, or let's say what I do generally in our ecosystem is go always with the incremental kind of a migration, right? Where you don't have to every time load your data into your data lake, a bulk amount of data, right? There can be a two approach generally I follow. One is the full load kind of a approach, like where you entirely dump all your data, process it, and make it available to the user, right? The second one is the ongoing changes, right, that has happened on the source. So we need to always choose a tool, or let's say a kind of a uh, architectures which can basically supports a change data capture kind of a thing, right? So there are benefits of change data capture, or let's say before change data capture, I just wanted to come to like what are the different ways, how do you capture this data, right, from the source. So there are three ways of data that is being there are three approach like which we generally use to get this data in our platform. One is the query based, right, where you write a kind of a query based on some primary key, a range, or might be a timestamp column or the modified column. You identify the changes and you dump that data into your system, right? The second one is the event based, right? So where something has happened in the database, you trigger an event and basically send it to some other notification service so that you can identify what data has been changed and you capture those data in your system. And the third one is the change data capture, or let's say transaction log based kind of approach, right? Where you rates the log of the transactions, or let's say log of the database, and you start capturing the changes that has happened on the source, right? So each approach has its own pros and cons, but what we basically choose is the CDC based approach, like where any change that has happened in the source, we read the transaction log and basically capture into our target system. So what solve this problem is the data freshness, what you say, right? Anything happened on the source, you are capturing the changes and you are basically providing that to the end users. So that is what we can use like for solving the data freshness kind of a problem. Okay. Coming into the data consistency, right? So I think data consistency has been always been a challenging task for us because we don't have any control on our data source, right? So that is being controlled by some backend developer or might be some other teams, which have the freedom, like they can do any changes based on the need what they have, right? But as a data consumers, we need to make our system in such a way like we identify those changes and we basically replicate those changes in our system, right? So there are a couple of things we can define here. You can basically build an automated process, or you can define some kind of a process within an organization, which helps you to act sudden in a manner, right? So what we can do, what we did in the automation is like we build a data quality kind of a framework, right? So what data quality does was like you basically define the business rules, what is being needed, you integrate that with your pipeline. If anything goes wrong, you get flag it out and you basically inform to your end users like there is being a data consistency or data quality check failed, and we'll have a look on it, right? This also can be solved in a two-way. One, you inform the users, or second, you can have an auto heal kind of a process, like where you identify the issues. If there is a way how you can automatically fix it, you basically call that module and re-backfill or might be backfill this process, right? So that is the second one. Coming into the schema evolution, right? So again, as I said, like in a startup kind of a world, right? So the features keeps on going release like every 2 weeks or might be every 1 week. So there is always being a challenging, like your schema on the source will always be evolved over a period of time, right? So there is n number of changes that is happening on the source, right? So you need to make sure like you choose a data extraction framework in such a way like those changes you should be able to identify, right? That is one. Once you identify, you should have a let's say data lake capability, a data lake capable of handling those kind of a schema changes, right? So what we do is we build a custom framework like which can first, let's say that the approach is very simple. You get the data, you load it into your data lake, you have a data catalog being captured, right? So you have one schema that is being defined. Some particular time, or let's say some particular developer change the schema in the source, right? What we do is we make sure like the incremental changes go with the schema evolution kind of a module, which basically have a pre-checks like what schema the latest data is being having and the schema that is being registered into the catalog. We do the comparison between those, and we basically define a rule like where if there is a new column that is being added, we add that particular column and basically register into the catalog. Right? That solves the one of the problem. Right? There can be a scenario where this schema cannot be applied to your data catalog. Right? In those scenarios, what we do is we flag it out like there is schema changes that cannot be handled into the data lake, and we might have to do the full load again so that that particular schema can apply into the data lake. So these are the few solutions what we applied into our schema evolution journey. There are a couple of tools, let's say technology being available in the market, like which helps you to identify all those schema changes by themselves. But what I generally prefer is writing some custom logic so that your use case might be different than what that particular tool is be providing. So this is how someone can deal with schema evolution that has happened in their system.
Yeah, that's true. Because most of the systems today, they might talk microservices, but I feel like somewhere down the line it's an happy monolith. Happy monoliths are everywhere. Like even the best of the best companies still have happy monoliths, right?
Agree.
You can't get away if your organization is old. to a greater extent, there is obviously an monolith that you have to deal with, or else there will be some decision making process that would have happened in while the company is getting built where it still stays monolith, and you don't want to change it at any time. But specifically talking, there are hundreds of changes that are happening in a market, right? So everybody is moving to the microservices. They're keeping some as monoliths. That's absolutely cool, but that's not the same, right? When it comes to an automobile company, they have to make sure that they at least go service oriented in terms of the data that they're keeping for the machine learning model that is getting batched over a course of time. It's not like one day's data, it's 100 days of data that is being hundreds and hundreds of days of data, not just 100 days, it's hundreds and hundreds of days of data that's been collected in one SQL or somewhere else. But still there is a challenge of segregating them into different domains, into a different set of problem statement. Like one of the problem statement is ABS system had a different kind of an schema once they had rigged it up as a monolith, and now they want to convert it as a domain driven system that is storing data in a different form factor. There are different teams working on different chunks of the data of the same data set that was there. So have you seen any of these kind of problem statement? Then how did you try to solve them? Because a lot of times when we talk technology, a lot of times when we talk, this is what data mesh or data lake or any data jargon that is getting attached to a data technology is coming up with, but there is still a prevailing problem statement. So let's just address this question at the last so that we convert everybody to know that, what, it's never a complex piece of puzzle, but you need to have some insights before you approach it that right way. So how can an organization who still has a monolith which is working absolutely fine somewhere down the line in their production now try segregating the data from a monolith and make it domain driven?
Okay. Okay. So just few questions over here, right? So are you more concerned about like how a backend should change from monolith to microservice kind of architecture? Or is it something like we are looking for some data consumers who wanted to access this data in such a
Yeah,
way like they are domain driven?
I think the second one would obviously work fine, where there's a database and there are consumers who are coming up, and now we want it to go data driven. So how is that? I think backend logic changing, it's obviously, and not just a work of an overnight engineer, right? It's
Correct.
obviously there, but data as one of an whole chunk, it's still JSON to me to some extent. But
Hmm.
when it goes on production, it's hundreds of bytes of data which comes and sits every second, and I'm saying one part of a schema, and hundreds and bytes of data is coming and sitting in other parts of the schema as well. So that's my real question
Got it.
about.
Got it. So I think I have not faced this issue like where I need to deal with the monolith kind of a data source and basically build the platform. But I can definitely tell you like what my approach would be right in such scenario. So having said that, again, like as you said, like there can be a monolith database or let's say monolith architecture which stores all your data into one single database, right? And it can have hundreds of tables, like hundred of columns, like each table having hundred of columns, right? So the big challenges here would be like identifying the changes that has happened and basically capturing into your target, right? So the first thing what I always think on building the platform is like you basically dump the data as it is into your data lake first layer, right? So you don't have to connect your data source again and again. So let's say you dumped all the data into your data lake. Now, accessing this particular data by our users would be a very kind of a solving a puzzle kind of a thing, right? Like you have a very big data, big schema, like where you need to identify what particular columns means and then basically face the data, right? So what I can think of is building another layer which solves the problem, like a kind of a approaching with the data model kind of a concepts, right? Like where you identify the dimensions and the facts what is needed for the user, right? A dimension and a fact are nothing but you basically identify what transactions a company is dealing with and you categorize that transaction into different scenario, right? So a very simple is like let's say you have a orders kind of a fact table like which stores all your order transaction into one single table. But whatever attributes or whatever dimensions that particular order is holding is being captured, or let's say is being kept into a separate dimensions table which has a linkage to that particular order. So our users, if sometime they wanted to get the data, they can just do a joins and they can extract those particular data, right? So one layer you have all your data source. The second layer you have a data model that basically combines a fact and the dimensions, right? So again, you give the access to data consumers to that data model. It's always becoming a tough for them to join and then basically aggregates the data and come out of the insights out of it, right? So in such scenario, what I think of is like building a third layer where you start becoming a domain driven, right? You understand there is a finance team, or you understand there is a sales team which wanted to understand the sales that has happened on a daily basis, hourly basis, or might be weekly basis, right? So you can start building a materialized view kind of a table, like which stores all your sales data and basically hand over that particular table to the sales team, and they can get all the data needed from that table, right? So this is how I can approach solving this particular problem, like where you have a data that is in a monolith architectures, and you define a platform in a three layers, like one being a raw layer, a second being a data model layer, or let's say a data model layer, and the third being the transform layer, which aggregates the data and defines the domain, like what it need to be solved.
I think that actually summarizes most of the things, right? You know, like I still remember learning about service oriented architecture in Ian Somerville's book, and in Ian Somerville's book, he literally talks about the moment you think schema change, be ready to be a right engineer. Like that's the kind of an line that comes up. It's not quote unquote the same line, but it still really says that, the moment, like I just, like, let's just end this podcast with one last question. Like, how was your first data schema change problem statement in production, and how did your team solve it, or else you try solving it over a course of time? And you have been very big on Neo4j as well, so you guys have been working on some Neo4j graph databases as things like that. So how is adoption towards a new database also changing the way you think in the market today, and how is it actually being its own engineering problem statement on its own? So that's my question.
Okay. Okay. Now talking about the schema changes, right? I think most of the time what we have been seen is like we cannot stop the schema to be unchanged, right? So I remember last time, like when what has happened in our system was like I think at the beginning we generally don't think about the schema evolution, right? We start building the platform like which can get the data and basically make more use of it, right? So you don't think about the very scalable kind of architectures. The main goal of the data engineer would be like how can you make your data usable so that more and more use case can come, and based on that you can start evolve, right? So the same approach we started, I mean, in our last company, and what we saw is like there was some schema changes that has happened in the source, right? So the platform, or let's say the architecture what I have been designed was there is a schema on read and schema on write kind of a problem statement what you do, right? So what does this schema on read is like when you read the data you define the schema and you only read those particular data sets what you have in the schema, right? Second, schema on write is like you have a data source, you read all this data while writing the data, you define the schema and you write only those data in your target, right? So what we choose the approach was schema on write, right? Sorry, schema on read. So we provided the schema, and the schema is something, let's say, a 10 columns kind of a table. It goes and it reads that particular data set and started populating into the target, right? So the pipelines does not break. There was nothing break, but what has happened was there was a new columns that has been introduced because of some feature addition, right? So that particular column we were not able to introduce in our base table, right? The problem was again there was a different layers which does this aggregations and provides a separate view of the table, and that is being used by the end consumer. So the end consumers was expecting some new features that has been happened in the source, and they wanted to basically see the visibility of the features how it is being going, right? But we were not able to give. So that was the one challenges what we saw, like which we were not able to basically apply the change that has happened on the source, right? Second challenge is what I remember is the data type sense, right? Mostly people do something like this, like they have some kind of a varchar 30 or let's say some characters. They have a need like where they can increase that character into 64 or might be 128, right? Though a database in the system might support it, right? But the data type, what we have defined in the lakehouse, sometimes, or let's say a data lake, might not be supported, right? So that breaks the system, and that basically start happening like the data capture issue will start happening over there. And so this was the second challenge is what I saw in my last couple, I think last organization what we faced, right? And the last questions, can you just repeat one more time?
So I think there is always a new set of migration that
Got it.
always happens. Like
Got it.
let's say from
So
an SQL DB to an SQL, or else Neo4j is one of the examples where everybody wanted to go to graph databases, and there was a new challenge that they came up with.
got it.
Graph
Yeah, yeah.
databases
I
are
think
good. There is always a challenge. So that's migration challenge that I wanted to.
got it. So I think it can happen two way, right? The data source keeps on adding, right? So again, there can be a need for the application or might be the backend team to introduce a new database so that that can suffice their use case, right? The similar way that data will be needed to the analytics user so that they can combine this data to the existing data and then they can make the insights out of it, right? That is one part. The second part, as you said, like a data science use case, right? As you said, like some data scientists might wanted to do some kind of a recommendation algorithm, and they prefer to go with some kind of a graph database which they wanted to introduce, right? So this is where uh, what we need to think of is like always try to divide your data platform into different layers, right? So one is the data ingestion or data extractions framework what you can build, which the job is to connect to this data sources and dump it into your data lake, right? Nothing else it does, right? So let's say tomorrow if new sources is being added, you can just write one connectors which can extract this data and dump it into your data lake, right? That particular problem will be solved like if you have a layers that is being built on the platform. The second part is like something understanding the data science use case, and they wanted the data to be available in the graph database, right? So what I consider this is a reverse ETL kind of a use case, right? Where a data scientist want your data in a certain format into their graph database. So what we do is we collect this data from the data sources. We might need to aggregate this data combining different source of data like NoSQL, MySQL, or might be some other two sources aggregates in such a way and basically dump this data into the graph database, as you say, like Neo4j or Amazon Neptune, like what we have generally. So those data can be dumped into those particular sources and can be exposed to the application user, right? So this is one use case like where you wanted to do a reverse ETL. There are some other use cases like where a backend applications, right, or the front end applications need the data into a relational database. So what we generally do is we collect this data into the data lake, we process it, we dump back to the Postgres or let's say a MySQL kind of a tables, and they basically are being fetched from the applications which has the direct connectors to the direct connectors to the let's say relational kind of a database. So this is how I solve like the problem. Like when you basically to just summarize, right? You segregate your layers, build a data structure of the data ingestion framework, and also build a data, let's say, dump or kind of a reverse ETL kind of a process where you can backfill your data back to the some processing layer or let's say the application database which wanted to read that particular data from.
True, true. I think migration, man, migration literally teaches you hundreds of things. Addition teaches you hundreds of things. So I think there's a lot that goes behind. I think this is not the end of the podcast that we wanted to conduct with Jitendra or else any other data professionals. There are tons and tons of data insight and the data technology podcast that we are really wanting to do with a lot of developer advocates, technical architects, and who not. We really want to address the best of the best problem statement of data technology. And I think Jitendra, thank you so much, sir, for being on the show. It means a lot. You know, it's a Sunday evening where we are still fresh with the data insights because Monday morning there is a production issue that's waiting for us. And we are about to solve it over a course of time. And thank you so much, Jitendra, sir, for being on the show. It means a lot.
Okay, thanks, Vishwas. I think I think two things I learned on this broadcast, right? One, I was able to recognize what I have been done in my past careers, right? That that having said, like I could remember like what are the challenges I faced, and I try to give all the solutions what I basically implemented over a period of time. And second, like looking on the data security is being expect, like I can say like that is a very critical, and we always think of that particular aspect, right? And every data engineers or every data users, right, they should think on the security aspect. Yeah,
That's true. That's true. I think thank you so much, friends. This is the end of the broadcast. Thank you so much, folks.
thanks.